I'm Julien, the Cosmos SDK engineering lead for the Cosmos SDK. I'm going to talk about what we've been basically doing for the last year, mainly Cosmos SDK V2. But before starting, I think most of you know what the Cosmos SDK is, but let's just go back to explain what it is, what can it do for you and your application. So the Cosmos SDK is basically the framework to bring software blockchain, mainly app chain, as we're in the Cosmos ecosystem. But you can build basically anything you want, from decentralized finance application or different application that you have like with Akash and everything, or basically your own other kind of application you're able to do with the Cosmos SDK. As well, it is a framework that is limitless. So you have to build the building blocks of your blockchain that we call modules, and know that is native code that's being used in your blockchain. As well, you're not limited by a VM. So you're free to use one, as there is that have been existing in the Cosmos SDK, but you're not limited by it. And you get full control over all the messages, over the site management, or even the tokenomics of your blockchain. So next to that, it's like really a framework and an SDK, so it's plug and play. So you define in your blockchain, this is the application layer. Earlier, Comet BFT mentioned that they are the consensus layer. The Cosmos SDK is the application layer of your blockchain. And it's plug and play because we already developed more than 20 modules to help you ship faster. Basically, the 20 modules that we have, like just to mention a few, like this is basic functionality that you do not need to recreate when you're building your blockchain. There is obviously the bank module to allow you to try to bank transfer and send denim, etc. The governance module that many of you might like or hate, that allow you to have on-chain governance by submitting proposals, or the POS module, as it's by default a proof-of-stake chain. So we have like 3 modules to handle that nicely, which are staking, slashing, and evidence. So as I mentioned as well, you can tweak anything you want for tokenomics. Like you have the mint module that allows you to define any mint function or an inflation rate for your tokens. And as well, a distribution module that allows you to resolve rewards, etc. And last but not least, one good module is as well chain upgrades. You want, when you made a chain in your module, to upgrade it via consensus upgrade, so the upgrade module allows you to do that very easily. As I mentioned earlier, this is extensible, so as a chain dev, what you really care about is building your application and your whole module. You shouldn't care of how the inside of the Cosmos SDK work, it's all abstracted for you. You as well, many other entities that develop other modules. For instance, within the Interchain stack, you have obviously the IBC modules that you can easily add to your chains, and you have as well many VMs, like an EVM with EVMOS, or Cosm wasn't the most used VM in the Cosmos ecosystem, as well JavaScript VMs, such as the one developed by Agoric. So you might have seen this image quite often, actually, at Cosmoverse, but this is a great representation of all IBC connected chains. And here, if you look at this, 99% of them are using the Cosmos SDK. Like Comet BFT allows you to use another application layer, but most of changes stick with the Cosmos SDK because it's going to use some other. I'm not even sure if there is any live chain in this screenshot that actually do not use the Cosmos SDK, but there is currently live, I think, only 2. So before I dive into V2, we'll get a bit technical. We have to understand a bit how the VOXX works. So as I mentioned earlier, the Cosmos SDK is the application layer. So you define all your business logic within your modules. You define extra validation that will run before the TX with anti-handler. And the application is really the state machine. So we do not handle any consensus or networking. This is all done by Comet BFT that implements the 10-limit consensus algorithm. So this does the processing of the block, the peer-to-peer, etc. The Cosmos SDK just interacts with extends to the ABCI interface, which is quite handy. So internally, how really it works, it's a bit like currently one big monolith. So we have something that we call base app, so that does the implementation of ABCI 2.0. So it implements the prepare and process proposal, it implements checktx, finals block, or all those ABCI methods. And then within that, it does all the execution and running the check with anti-handler, executing the beginning and blocker, for instance, of modules, or executing a transaction. And thanks to ABCI 2.0, we even can have, thanks to prepare and process proposal, an application side mempool that can be defined by the application directly, as well as the store handling and more. So to simplify this and to not have to let you always configure that manually, we created something in the price version that we call runtime. And runtime basically hides the complexity of base app and create base app and basically handle all the module wiring. So we really want you to only focus when it's needed on the module wiring. So you just pass a new module into runtime. It will configure the module manager, and you just can really focus on your modules. And next to that, we have a third component that we call server. This component basically allows you to have the start comment of your application. It will start base app, it will start commit, and it will just all be packed into one binary. So we actually work on this, and still, as you know, O50 and all the previous releases. So we have an upcoming release that we call O52, Olympus, that will come with 2-year support because of the change we're going to make later. So that means in that version, we added ComMapDFT V1, which is the latest version of ComMapDFT. We finally are coming with stable module APIs. So we have all the core APIs for module and for the application that are created in a package that we call core, Cosmos SDK core. And this will be tagged V1, which means that module between upgrade of Cosmos SDK will start breaking. We finally found the perfect APIs that we like people to use when they develop their Cosmos SDK modules. As well in that version, we extracted all the modules. Many people, when they are building a chain, maybe need to make a change in bank because they don't like it, they want to add hooks or whatever, or they want to make a change in other module. Before that, you had to fork the whole SDK just to have a 3-line code change, which was not super. So what we did is we just extracted all those modules. Now they are smoothly replaced in your blockchain and just use a normal Olympus, which is easier. You don't have to maintain a fork and do basically the work we're doing. We've added a few new modules as well that are going to be Olympus compatible. Protocol pool. To mention, this is basically, we extracted the community pool that exists currently in distribution and we put it in another module. And this module basically enhances the capability of the community pool. Now the community pool is just a normal module account and you're able to have continuous founding as a community pool for continuous founding or easily fund a community pool, etc. We've actually upstreamed the work from the Osmosis chain and upstreamed the Epoch module, as it is a widely used module, and some people wanted to use it. So we actually make sure that that module exists, and now it's maintained by the SDK, and as well stay compatible with the Osmosis module. And we have added a quite cool module that is X account that I will give a workshop tomorrow to see how it works, which is a module that has a smart account compatibility. You're able to basically define your own account logic, authentication logic directly into it, but I'll dive into that tomorrow in the workshop. We've added, again, more module improvement, like XGov. For instance, we've added optimistic proposal, which is a proposal that if you do not vote no, will automatically pass, which is quite handy for recurring tasks, and as well some staking improvement. And before I go to V2, Olympus, that is maintained this for 2 years, is the last version of base app and the O50, the O0 architecture, the V0 architecture, which means after these 2 years, everyone can, and already today, everyone can embrace the V2 world. But we want to give you enough time to migrate to V2. There is not too many changes that need to happen. But this will be a long maintained version, a long-term supported version for what is currently existing. So now let's dive into actually what V2 is, what it changes. So at the beginning of the year, we were like, okay, we want to actually make the SDK even more modular, easier to maintain, easier to swap things that are not super easy to swap because of base app being a big monolith, and make our life for you and for us as well easier. So you may say, yeah, base app is battle tested. If it ain't broke, don't fix it, right? Well, we've come up, as I've said, with something easier to maintain, with some performance improvements thanks to the simplification, and as well, you almost have, because it's really the core layer, as I will explain later, you don't have actually anything to change in the application, or maybe 1 or 2 lines. And because we don't want to break people, and we care about DevX, we will ensure that there is feature parity, at least maximum feature parity between Olympus and V2. So if you migrate from your 52 to V2, little almost nothing will break, at least on the client side and on the code side. So as well, why V2? You might be, oh, where's V1? Well, there will be no V1. We changed so much that we decided to name it V2, but the advantage of having finally a version that follows Simver is bye-bye breaking changes. Like, we will stop doing API breaking changes. Something that we hear often from developers is when they migrate from a version for SDK to another, they have so much to modify in their code because we modify the API here and there, always to improve the UX eventually. But all of that led to now two of us being able to tag V2. And V2, thanks to this modularity and swappable components, allows you to have even more control over your app. You have even more control over the core layer. Before, you always have control over the modules, but now the core layer as well have swappable components. And as well, we're able to release faster, non-breaking changes, but just add like features or patches very easily. And that won't be like a big upgrade like you have to do when you migrate from, for instance, 047 to 050. So how does it really work? What does V2 really entails? So we have something called a state transition function that we call STF. That is something that is stateless and really handles, there is really have like five methods on it that handle the transaction validation, like Bicep did, the delivery of block and execution of transactions. So basically, we'll just execute the block. It handles the queries and simulation. So on this graph, I'm not sure we can see, yes, we can. We have the consensus server that we'll explain later that will pass to decoded transaction to the state translation function. And then deliver block, we basically run the same module flow like it did on base app, which is pre-block, backend block, the transaction, and the end block. So on the module side, nothing changed, but the core layer has changed, as you see. So we have then created runtime V2, which is basically a runtime that we had, but doing another kind of wrapping. Instead of wrapping base app, you write STF, and it does now the handling of Genesis and storage via App Manager as STF is stateless. And the same thing changed. We made sure that when you have your app.go, when you have your application, if you do the migration to V2, not too many things will change. We want to make it easier for chains to migrate to V2. Additionally, as I mentioned, the server part, as well as now a V2 component, we try to split the big server function of the SDK into multiple servers. So now you're able to extensively extend server and create any server that you want. But by default, for feature parity, we still provide a gRPC gateway. We have a new REST server because of the new API, the new handler API, the telemetry server, and last but not least, obviously, the Comet BFT consensus server. I'm going to just dive a bit into that now, as it's like the pretty cool thing. The fact of, because we have been able to split everything, we have been able as well to push all the way to the edge Comet BFT. So we're part of the Interchain stack, so obviously we provide a Comet BFT server. That Comet BFT server implements ABCR 2.0, like it did in base app, and they just be doing all the integration with Comet BFT. But say for a second that, okay, you like the Cosmos SDK, but you want to try something new. You're like, okay, Comet BFT is great, but I don't care about ABCR. I want to use something totally different. Well, now it's possible. For instance, if you're building a rollup, like Rocket, for instance, what they do is they fork Comet BFT and do their thing with a sequencer. You're able to just instead rewrite a server, a consensus server that will just directly talk to the sequencer, and that's it. You can just swap it without having to do anything else. So are you not convinced yet to migrate to V2 when it will be released? Well, there is even more things maybe that you might say. For instance, modularity doesn't matter to me, or always use the Comet BFT default, or you're a bit worried about moving to something new. As always, new code base means new risk. Well, we have some great performance improvement to maybe try to convince you. For instance, runtime we use by default store V2, which is a rework of the store layer of the Cosmos SDK. So store V2 uses AVL V2, which is a 10x faster than AVL V1. So you'll see if you migrate from 50 to V2, or from even 52 to V2, you'll see an improvement there as well, thanks to the rework and the simplification of everything, and the removal of mutexes and stuff. We've been able to make query even more faster. And we've seen a small TPS increase as well. We're going to do more work on SDF, and I have an alternative version of SDF, as not every change one parallel execution, but we'll be able to bring as well parallel execution within SDF to even more increase the TPS metric. So this is like benchmarks from Matt that he did at DevMost 2024. This is just to show you a sneak peek of what ARVL V2 entails. So as you see, if you're on 047, the operation per second for V0 are like pretty low, but if you migrate to V2 and ARVL V2, you can see a V2 hot heavy cleaves. This is the interesting one, is like 10x faster. Matt has gone in his talk that I'm doing here. I'll invite you to all watch it. You can just Google this, and it was pretty interesting. So as well, something that I want to make clear is like we modify only the core layer. So things pretty much stay the same for you if you use the same default component. So the SDK is currently more of a framework that provide good default, but we wanted to make it more of an SDK, so people and power users can pick only the part that they need and replace the part that they don't need. But if you want to keep using the SDK as a framework, that is possible. The Cosmos SDK provide all the good defaults, and you just have to care about building the building blocks of your module. But if you really want to dive into switching STF or switching the different implementation there and do some tweaking, that is something that is possible right now with V2. So stay tuned for more. There is actually even more things that are happening that are not really V2 related, but will be coming with V2. For instance, we've been looking into ways to build modules in another language than Go. Like some people really like Cosmos or VMs, not only because they are VMs, but as well because of the language. So we have been working on making native module, and we're currently working on making native module in Rust. There will be more article coming on it, and I invite you to look out the social media for it. As well as I mentioned, the parallel execution STF is something that we're still working on, and that will be released as well very soon. So that was a talk. You can have a look at more on, obviously, the docs website, and you can as well talk to me later here at Cosmoverse.